Okay, today's word problem, we're going to be looking at the distance formula. So it's always the first thing you want to do when you're solving a word problem is to read it clearly and make sure you understand what it states, and of course make sure you know what you're looking for. Generally, you're going to let X represent the quantity that you're looking for. So here we have it. Two cars are leaving from the same point A and are traveling in the same direction. The first car leaves and is traveling at 30 miles per hour. The second car leaves 30 minutes later and is traveling at 60 miles per hour. How long does it take the second car to catch up with the first car? Now, as I mentioned before, it is possible in some word problems to solve it using trial and error and a little bit of common sense. We're taking the approach that we're going to set up an equation. So obviously this one deals with a distance formula, so you need to know what the distance formula is. So here's the formula. Distance d is equal to rate of speed multiplied by the time. So if the rate of speed is, say, in miles per hour, then the time you want it to be in hours. If it's, say, centimeters per second, then you want the time to be in seconds, and so forth. So just as an example, if you're traveling at 50 miles per hour and you go for 2 hours, notice the hours here cancel out. You get 2 times 50, you get 100 miles. So if you're going 50 miles per hour for 2 hours, you're expected to travel 100 miles, assuming you stay at that speed constantly for two hours. So if you want distance, you need the rate of speed and the time. In the second form of the equation, that formula, all I did is I took the formula for distance and solved it for t. So time is equal to distance divided by the rate. So for example, if you know you went a total distance of 100 miles, that's d, and you're going at 50 miles per hour, if you divide that out, that gives you the time 2. In this case, 2 hours. So you know the time would be 2 hours. If you travel at 100 miles in the third equation here, 100 miles, and it took you 2 hours, you divide that out, you get the rate, 50 miles per hour. Okay. So in this example here, you can see then that in half an hour, the first car, that's 30 times 1/2 is 15. So in 1/2 hour, the first car would have gone 15 miles. In 1/2 hour, the second car would have gone 30 miles. That's 60 times 1/2. Okay. In 1 hour, the first car would have gone 30 times 1, 30 miles. The second car in 1 hour would have gone 60 miles. That's 60 times 1. So that kind of gives you an idea as to how to figure out the problem. And I made it pretty straightforward by using round numbers here, but I could have made it easier by selecting other speeds, like say 25 and 32, made it a little bit more difficult to figure it out. But with the figures given here and using the formulas, hopefully you're able to figure it out without setting the equation. But let's go ahead and work this out. Okay, so they both start off from point A. Okay, that could be a town or somebody's house or whatever. And then the first car takes off constant speed at 30 miles per hour. So it goes on this line here. Okay, 30 minutes passed, or 1/2 hour. 30 minutes is 1/2 an hour. 30 minutes passed, and then the second car takes off, going faster. So obviously it's going faster, so eventually it's going to catch up. The question is, how long does it take? Okay, so they travel the distance A to C. So the distance A to C then is the point at C then, for example, is the point where the second car catches up. So from A to C, at the point the second car catches up, the distance traveled by both cars is the same. So basically what I want to do then is set up an equation that represents the distance traveled from A to C for the first car, and a representation for the distance traveled by the second car from A to C, and those should be equal. That would be my equation. Okay, so here's the way we're going to set it up. I'm going to let t, or time, equal the time required for the second car to catch up with the first. Okay, so obviously the first car takes off and it's gone for half an hour, and then the second car takes off. So t is going to represent the time it takes for it to catch up. Okay, so 60t, okay, that's using the formula distance is rate times the time. So 60 times t is equal to the distance traveled by the second car as it catches up with the first car. So this distance from A to C then would be the same thing then as this right here, then would be the same thing as 60t. Okay, that's 60t. Okay, so now for the second car, it's gone for half an hour, so 30 times 1/2. 30 times 1/2, that's 15. So by the time the second car takes off, the first car has already gone 15 miles. Okay, then the second car takes off, and it travels for t hours. Well, the first car will travel 30t in that time. So if the time t to catch up is so many hours, then the second car, or say the first car, would have to travel that distance also, 30t. So the distance from A to C is represented by 60t, and that's the distance traveled by the second car as it catches up. At the same time, the first car goes 50 plus 30t. Okay? And then at that point, the second car has caught up. Well, these two distances have to be the same. So my next step then is to simply set these two equal and solve for t. So here's the equation that I set up. 60t should equal to 30 times 1/2 plus 30t, which of course is the same thing as 15 plus 30t. So this equation becomes 60t equals to 15 plus 30t. So if I subtract 30t from both sides, okay, solving for t, subtract 30t from both sides, the left side will give me 30t. That's 60t minus 30t. And that, of course, subtracting it from the right side, 30t minus 30t gives me 15. So I get 30t is equal to 15. I divide through by 30, so 30 divided here cancels it, I get t equals to, and 15 divided by 30, if I reduce that, that's 15 over 30, that gives me 1/2. So that tells me that the value of t is 1/2, and this is in hours. So this tells me then that the time it takes the second car to catch up to the first car is going to be 1/2 hour. And you can easily check this out, right? Because 1/2 times 60, the second car is going 60 miles per hour, so 60 times 1/2 gives me 30. So in 1/2 hours, the second car has traveled 30 miles. Well, how far has the first car traveled? Well, it has a 1/2 hour head start. 30 minutes is 1/2, remember, 1/2 hour. So 30 times 1/2 is 15. And then another half hour, which is the time required for the second car to catch up, 30 times 1/2 is also 15. 15 and 15 is 30. And that's the way you solve the problem. So again, you can solve some of these problems trial and error, using a little bit of common sense and knowing your basic formulas. But if you want to make it a little bit easier on yourself, know how to read the problem, how to select the variable, and then form an equation involving two expressions that involve the variable, which is what I did here, and then solve the equation for the specific variable, and you have your problem solved. Okay, we'll continue with, again, other problems involving different types of word problems that you could encounter in a basic algebra class. And as always, if you have suggestions and other types of problems that you want to see, please post your suggestions. And again, if you subscribe to my channel, I will consider your request. And as always, thank you for watching, and please subscribe to the channel. We'll see you next time.